We are being asked to simplify this exponential expression with rational exponents, and we're going to simplify this using the same rules we did with whole number or integer exponents. The first thing I'm going to do is I'm going to apply this power to power property to where I multiply these exponents on the inside of this parentheses by the exponent of 5/6. When I do that, what I will get is in the numerator, I have this x to the 1, this y to the negative 1/4, and now I have an x to the negative 1/3. This is the first factor that came as a result of that multiplication, and then a y to the negative 5/6. And down in the denominator, I still have this x to the 1 and this y to the 1. All right, and just to quickly talk about where I got these exponents up here. This first multiplication was 5/6 times negative 2/5. And what I'm doing there is I'm multiplying negative 2/5 times the 5/6. When you have negative fractions, by the way, you can put the negative just to the numerator or the denominator, actually, but not both, just either the numerator or denominator. I always give it to the numerator. I'm going to cross cancel here, cross cancel these fifths, cancel this common factor of 2 between the 2 and the 6, and then multiply those results straight across to get a negative 1 over 3, which is where I get this negative 1/3 exponent right here. And then the second multiplication was this 5/6 being multiplied by the negative 1, and that's not too interesting. Negative 1 times 5/6 is just negative 5/6. That's pretty straightforward, and that's where I get this factor right here. Okay, so that first move was simply to get rid of those parentheses by distributing that exponent through. Now what I'm going to do is I'm going to apply the property of negative exponents to these negative exponents right here and those factors. What I'm going to do is I'm going to move those factors down to the denominator and make their exponents positive. And so that would look like this. I have this x to the 1 up in the numerator. I have in the denominator, I have an x to the 1, a y to the 1, and now I have this y to the 1/4, and this x to the 1/3, and this y to the 5/6. And again, these last three factors came from the numerator. I moved them to the denominator and took away the negatives in their exponents. That's just using the definition of negative exponents. One thing I'm going to do here now is start to clean things up. I'm going to cancel this common factor of an x in the numerator and denominator, just getting ones left over. And now I'm going to combine things. What I'm going to combine here in the denominator here is I'm going to combine all of these factors of y. When I combine these factors, I add their exponents. So what I'm needing to do now is I need to take the 1, I need to add that to 1/4, and also add 5/6 to the mix. To do this addition, I need to find common denominators. I'm going to use the common denominator of 12. So 1 is 12 over 12. 1/4, I'm going to multiply both the top and the bottom by 3 to get 3/12. And for 5/6, I'm going to multiply the numerator and denominator by 2 to get 10/12. When I add those all together, I'm going to get the same shared common denominator of 12ths, and 12 plus 3 is 15, plus 10 is 25. And so when I add those exponents together, I get 25/12. What that means, again, what that was I was putting together these factors right here, and I did that by adding their exponents together. And so now, what I have on top is I just have this 1 because I've canceled out those x's. In the bottom, I have this x to the 1/3. And then for the y's, I have y to the 25/12. And that is my completely simplified expression.